Well, this is Dr. Frederick, just with a review of the assumptions of the analysis of variance, which we call the ANOVA. The three basic assumptions. Essentially what you're doing is this, is you are sampling from two or more populations. In fact, that's what you think that you're doing. That's why you're doing the test. Now, of course, your null hypothesis is that the characteristics of these populations, the means, and more importantly, the variances are all the same. And generally, the null hypothesis is just that the means are different, or I'm sorry, that the means are the same. The means of what? Some characteristic that you're measuring. And so the first assumption is that you're measuring some characteristic that's a quantity. And so you're using interval ratio data. The second assumption is that the populations, the characteristic, is distributed normally. It has a bell shape. So the middle values are very commonly seen, and the extreme values are not so commonly seen, and has this bell shape. And the third is that the variances of these populations are the same. That is actually the true null hypothesis. More commonly, we talk about the means being different as the null hypothesis. But if you start out with variances that are different in your populations, you just cannot get any sense out of your analysis, and you'll make a lot of mistakes. So when we talk about assumptions, what we're really saying is these things must be true for your ANOVA to be possible. If it's not possible, then you're going to find many ways to make a mistake in understanding what is true once you sample from populations.